Algebra 1, today we're looking at Unit 3, Lesson 7, the correlation coefficient. We have been talking about this, and now we're just going to dig in a little bit deeper today. Let's see how a good linear model is for some data. For this lesson in class, we're going to be working on a card sort and sorting through some relationships between graphs and their positive or negative correlation. When we look at this correlation R, the R value or the R letter is called the correlation coefficient. And a correlation coefficient is one way to measure the strength of a linear relationship. So the sign of R is the same as the sign of the slope of the best fit line. The values for R go from -1 to +1 inclusively, and the closer R is to 1, the closer it is to a positive correlation or a positive slope. And the closer it is to -1, the stronger it is to, or the stronger linear relationship, which would be to a negative slope. The closer R gets to 0, the weaker the linear relationship between the variables will be. Okay, so for this activity, Mrs. Clorn's going to be your partner, and I'm just going to go through and explain correlation coefficient. We're going to look through each graph and see how it's correlating. In graph A, you can see that all of the points lie directly on the line. That means it's a very strong correlation. So if it's strong correlation and we look at the slope, which is positive, we are going to match it up with our R equals 1 for our correlation coefficient being equal to a positive 1. For letter B, you can see that that graph has somewhat of a strong correlation. It is going positive, so we're going to be looking at the options 5, 6, and 7, which are our positive correlations left. And since it is evenly spread and they're fairly close to the line, I'm going to go ahead and suggest that letter B should go with our number 7, R equals 0.9. For C, when we look at C, we can see that these are a negative correlation now because it's going down and to the right. So are they fairly close? Yes, they are fairly close, but those points aren't exactly on the line. So instead of being an exact -1, which is the best correlation you can have, we're going to go just one step down, and we're going to call that an R equals -0.95. All right, for the last few, we're going to look at all of our negative correlations first and then move to our positive ones. So for our negative correlations, we have graph D, graph F, and graph G. They're all going down and to the right. The least spread apart one that we're looking at is going to be graph F, which means that since they're all on the line, that one's going to be is going to have a strong correlation, meaning that it goes with number 1, R equals -1. The least strong correlation is letter G, so we're going to look over at our correlations, and the lowest correlation for a negative slope or negative correlation is number 4, which would be an R value of -0.06. And lastly, in graph D, that one's kind of in the middle, so you can see that the points are scattered evenly, dispersed evenly. So graph D is going to have a negative correlation, and that one's going to go with your correlation coefficient of a -0.74. Next, we're going to look at our positive correlations. You can see that E and H both have a positive slope. They're going up and to the right. The graph that has the weakest correlation would be graph H. They're further away from that line, meaning that H's correlation coefficient would be R equals 0.48. For E, that one is stronger than H, and our only correlation coefficient left would be the R equals 0.65. So I'd like you to think about what the sign of the correlation coefficient tells us about the data. Well, the first thing that it tells us is that if it's a negative, it tells us that it has a negative slope. If it's positive, it tells us it has a positive slope. And then, it can tell us how closely it is to creating a line. All those points on a line would be a positive one or a negative one, and then the further they get away from showing a linear relationship, the smaller the correlation is. The second question I'd like you to consider is, what does it mean to have a correlation coefficient of 1 or -1? And like we saw in the graphs, to have a 1 or a -1, all the points line up on that line. So think about that, and also I'm going to show you a positive one and a negative one, which look like this. Some questions to ponder here. What might a scatter plot look like when its line of best fit has a correlation coefficient of 0.9? Well, we can see that since it's positive, it's going to have a positive slope. It looks like points that follow a linear model very closely. And if we wanted to sketch it, it would look like this. Next question to ponder, what does a scatter plot look like when its line of best fit has a correlation coefficient of negative 0.5? So the negative is going to mean that it has that negative slope. It's going downward from left to right, and it looks like a loosely scattered cloud of data that trends that direction. Next one line of best fit has a correlation coefficient of 0.88, and the other line of best fit has a correlation coefficient of negative 0.88. Han claims that the one with a positive correlation coefficient fits its data better. Is Han correct? Well, they're both negative or 0.88 away, so if they're that direction away, then they're both going to have the same correlation, which means they fit the same data. It's just that one is going up and to the right, a positive slope, and one is going down and to the right, a negative slope. This also means that as positive correlation, as x increases, y is increasing. And for negative, as x is increasing, y is decreasing. The residuals should also be examined in both cases to determine which data is fit by a linear model better. And lastly, why is it important to know the correlation coefficient for a linear model? Well, the correlation coefficient is a way to quantify the fit of a given linear model, and it allows you to compare the fits of different linear models for the same data that's happening. I know a lot of what we've talked about is information. Hopefully you can add it to your vocabulary in your book. But what you should have been able to do by the end of today and hopefully in class tomorrow is to be able to describe the goodness of fit of a linear model using the correlation coefficient. And you should also be able to match the correlation coefficient with a scatter plot in a linear model. We're going to practice with this some more in class, so be prepared to explain and justify and debate with your classmates. Have a great rest of your day, and we will see you in class.